today's subject is interior separations. Why am I standing in front of these shelves here? Because you can see that the shelves have their own load-bearing system, and behind this load-bearing system there's a wall which is drywall. In another part of the chair we have these shelves here, and you can see that there is no metallic columns here, but the system has been screwed on the supporting wall behind it. So this supporting wall seems to be solid, and the shelves are cantilevering out of the solid wall. Whether it is load-bearing or non-load-bearing, I don't know, honestly, but at least it's a solid wall and you can cantilever out from this. So here I'm at the reception, and if I look at both walls, they seem to be hollow. Let's take a look at this one. This seems to be solid. So here we have a solid wall, hollow wall, hollow wall, and they all look the same. Another hollow wall, and as you can see there are windows integrated in this wall. That's a particular situation because we have to link the ground to the ceiling. So this will take place in this area, and the windows are inserted in this wall. So statically they interrupt the link between the two supporting situations. But this has been accomplished in one way or the other in this case. So the situation is the following. We have two floors, and these floors are supported in one way or the other, let's say columns. And now I want to create a separation between one part and the other. And these walls here are non-load bearing, but they are separating this space here from this space. They might be acoustic or they might be visual, so everything is depending on what are my demands in terms of performance of this interior wall. So I have different solutions for this type of wall. They could be fixed, like for example masonry wall. They could be lightweight construction, as for example drywall, where I have studs and sills and whatsoever plated from both sides, and they could be taken out easily, but you cannot put them at another place, and they are still intact, but they will get destroyed when you take them out. Third solution would be a flexible wall system, where you can take this wall here and then put it in another position, still using the same elements that you have been using here. So this is a very primitive sliding door. You could imagine the rail being on top of the wall, and this being airtight at the ends, and then this would be a movable wall. Drywall, how does this work? Normally you have metal profiles, and you fix these metal profiles to the ceiling and to the floor. Then they are linked by posts, and then the whole thing is plated on both sides by gypsum board, either simple or double layer. So that's a rather simple system. The whole thing can be filled with insulation. And just to keep some dimensions in mind, it's multiples of 2.5 centimeters. So here, for example, the double gypsum board plating is 2.5 centimeters. One gypsum board is 1.25, and the space here in between can be either 5 or 7.5 or 10 centimeters. Those profiles exist in the catalog of the drywall manufacturers. Let's say this is 10 centimeters, and what I have to avoid is that there will be cracks inside this non-load bearing wall. Because it's not load bearing, it shouldn't receive any load out of the load bearing structure. So if, for example, this ceiling here can move, and this might be 2 centimeters or so, then I have to guarantee by integrating insulating materials that can take a certain movement of the ceiling, that I won't have cracks inside my non-load bearing wall. If I have bending here of, let's say, 2 to 3 centimeters, a particular attention has to be paid to sliding walls, because the sliding walls have to close tight on top and at the bottom, but I have to be able to slide them nevertheless. So if this is bending, the wall might be touching the ground. So in this case I have to limit the bending to a value that my type of sliding wall can take. In case of the sliding wall, I need special seals at the top, at the bottom, because I want this to be airtight. And so what is currently done is to have a sort of operating handle, and with this operating handle I might drive out particular seals that then achieve airtightness in driven out position. And if I want to move the wall, I have to move them up again, and then I can slide a wall. I have a space that should be subdivided with these moving walls, so they have to be separated in elements. And if I want to use this, for example, as one big lecture hall, so these elements have to be stored someplace, and this can be done either in a niche or alongside a wall. Try to provide a space where you can stock these separating elements. And to move them, there's a rail on the ceiling, and the rail has to link these storage facilities to the final position. And you can move these elements. They are suspended in 2 points with cardanic elements. It can be moved in different directions. Then afterwards the whole thing is closed up with the telescopic seals. So here I'm standing in a corridor, and you can see that one of these 2 walls must be load bearing, because it's in concrete. It's linked to the ceiling and it's linked to the floor, while the other one is supported by a horizontal beam in reinforced concrete. And then you have metal parts on top of it and in the lower part. In certain areas you have the interior walls meeting this non-load bearing separation from the offices to the corridor. So we have to do with different solutions. One would be a masonry wall. So this would be normally in Germany at least around 11.5 centimeters wide. Then we had the second solution, which was metal or wood profiles, and these would be connected with gypsum board insulation in between. And this then would be around 10 centimeters with double plating and 7.5 centimeters with simple plating. Third solutions might be system walls. So system walls could be made out of metal, for example. They might have a sort of elastic sill, and you could be able to take them out at one place and put them in at another place. And if you start drawing them, I would start in the same area as the others, around 7 to 10 centimeters. And these are prefabricated, industrially produced, and then taken to the building site. Flexibility is relative because you might have electrical installations inside the wall, and if you tear it down, you have to repair the electrical system. So one problem is that you want to make spaces airtight, but you might have suspended ceilings, and you might have screeds, or even double flooring. And the acoustic performance of the separating walls is much better if you go right to the concrete, but the building becomes much more flexible if you stop the separation at the suspended ceiling or at the double floor. So this then would need other provisions for acoustics, like for example continuity of insulation or an insulating block underneath the wall. It might also need a particular load-bearing system where you are foreseeing the positions of the non-load-bearing wall, and this might reflect on the suspended ceiling as well as to correspond to the possibilities to put the separating walls. And the whole thing will reflect in the facade as well, because at each mullion you could have a separating wall meeting the facade. So I've managed to build my wall, and now I want to enter the room. So I might be integrating door frame, and in the door frame I can insert the door. And this door then can be opened and closed. Could be a window as well. So that's one door solution here with a telescopic aluminum element. They could be made out of steel or out of wood, but at certain spaces I need openings in this wall. They could be doors, they could be windows. Air tightness is rather easy on 3 sides because there can be a seal. I will show you. You cannot understand me because I'm behind the door. And at the bottom here, there's a particular sill which moves up and down. So if I close the door, it's in downward position, and if I open it, so now it goes down, and here it goes up. So this is a simpler door frame made out of steel, and you can see that the closing element for the door has been integrated in the door frame. If I leave the door alone, it will close by itself. So here I'm standing next to a protective wall, and it protects the elevator from me touching it, or me from touching the elevator, because it could cut my hand off. And well, this is supported by a load-bearing system, and then plated with glass. And you can see that it protects the entry area of the elevator.